All right, last problem from number one, finding the fifth sum of this geometric sequence. If we're finding the fifth sum of this geometric sequence, it means we need to use our summation formula for the nth partial sum of a geometric series, which is first term times the expression 1 minus the common ratio to the power of n divided by 1 minus the common ratio. So, what do we know? Well, we're finding the fifth sum. We know that our first term is 2, and so we have a 2 right there. We know we have 1 minus our ratio, which is negative 4, raised to the power of n, which is 5, divided by 1 minus our ratio, negative 4, right there. Now, I probably should have told you could use a calculator on this one, because I don't expect you to know what 4 to the power of 5 is. It's 1024, but go ahead and use a calculator for this. But a lot of these problems we can do without a calculator. So let's type this into our calculator. I'm going to type it in like this. I'm going to do 2 parentheses 1 minus parentheses negative 4, close my parentheses, raise it to the power of 5, close the parentheses of my numerator, and divide it by, open a parenthesis for the denominator, 1 minus, open a parenthesis, minus 4, close your parenthesis for the denominator. Now maybe some of that's not necessary, but it absolutely will get you the correct answer, which is 410. Now, quick warning here. I know a lot of you would probably see minus and minus right there and say, all right, well, I'm just going to make those pluses. You need to be very, very careful with that. In this instance, since our exponent is an odd number, that would work. But if that exponent were an even number, that simplification would not work. So to avoid that issue, just leave it alone. Use your parentheses. Make sure you are raising the entire exponent, including the negative part, raising that to the power. So just put the parentheses around your r value. If it is negative, include the negative in those parentheses, and you will be okay.